back to the exact same place. You can make it coincide with the original by rotating it 360 degrees. All right, now, second example here says to do some drawings. However, we are going to, I don't know if I put enough in here. So it's talking about the vertices of triangle X, Y, and Z are at -4, 7, 0, 8, and 2, -1. First of all, we got some new notation here. A lowercase r means reflection. A capital R means a rotation. And so what we're doing is we're rotating, capital R means rotation. We're rotating every single thing by 180 degrees here. This one says to draw it, but we're not going to draw the first one. We'll draw some of the ones on the second one. And in terms of what we're actually going to be learning today is that we've got some rules today. So we don't really need to do a whole lot of like discovering what's happening. The rules that we're learning right here, those are our rules that we're learning right there. And actually, we will go ahead and graph it since we do have plenty of room down there. So the rules are, first of all, a 90-degree rotation has the rule, start with X, Y, and then take the opposite of Y, and then X. So basically, X and Y are swapping places, and the original Y value becomes the opposite. If you're going to rotate something 180 degrees, then you're going to start with your XY. The X's and the Y's don't swap places. They just both turn into their opposite values. So opposite X, opposite Y. If you rotate something 270 degrees, we'll see what this all looks like as well. The original XY, you swap the X and the Y in terms of placement. So the Y moves to the X position, the X moves to the Y position, and the X becomes the opposite value. So first of all, when we're talking about rotating, I want to be really clear about this. Anytime we rotate, this 0 is not a 0. That's an O. O stands for origin. So I'm going to put an arrow to that. That stands for, so origin, which is the point 0, 0. Capital R means rotation, 180 degrees, comma, O for origin. Origin, where the origin on a graph is the point 0, 0. This is where you are rotating something around. So basically, if you have a graph, and let's just go ahead and get this first example on this first graph here. Let's plot those points X, Y, and Z. So X is at -4, 7. So 3, 4, 1, 2, 3, 4, 5, 6, 7. So -4, 7. Y is at 0, 8, which is here. We got X, we got Y. And then Z is at 2, -1 right there. So there's X, Y, Z. We got our triangle. And it tells us to rotate this 180 degrees. And we're rotating it 180 degrees around the origin. So it says rules can be used to rotate a figure 90 degrees, 180 degrees, and 270 degrees about the origin, which means around the origin on the coordinate plane. Now, the other thing we need to mention here is that when you rotate, we are generally, unless it states otherwise, you are rotating counterclockwise, which means this way. Now, that's not super important to know right now because we've got our rules. So no matter what, if you use the rules correctly, you're going to end up in the right spot. But a 90-degree rotation counterclockwise around the middle of the graph would basically take this from here, and then it would rotate it around like that. 180 degrees is going to move it around about like that. 270 degrees would go all the way around and end up over here. So basically, most of this particular graph is here. So if we go with 180 degrees, most of it's going to be down here. Because it's going to be opposite of where it was. 180 degrees is like upside down, basically. It is not a flip, though. It's not a reflection. It's literally rotating around like this. And so that's what we're going to end up doing. So we're going to rotate this. We're going to use this rule right here. Opposite X, opposite Y. And so if X was at the point -4, 7, I'm going to write X prime right here. X prime is going to be at the point just take the opposite of x and the opposite of y. So that would be at positive 4, negative 7. So 4, negative 7. Keep x and y in the same spot that they were, but just take both of them to their opposites. So because x was negative, it now becomes positive. Because y was positive, it now becomes negative. So x prime is at 4, negative 7. Where does y prime end up? 0, negative 8. Yeah, there is no opposite of 0. But there is an opposite of 8, and it's negative 8. And then z prime, where's that at? Negative 2, 1. Good. So those are our 3 points for our rotation. So we'll go ahead and get those on there. So we're going to go over 4 and down 7 for x prime. So there's x prime right there. Y prime is at 0, negative 8, which is right here. So there's y prime. And then z prime is at negative 2, 1, which is here. So the rotation of 180 degrees right around the middle point of the graph, right around the origin, gives us that answer right there. Any questions on that? I don't know why I put 3 graphs here. I guess we only need 2, which is fine. Actually, you know what? We will do a third because we've got room for it. But let's do part B first. I want you to try B on your own. So you're gonna graph the original again. So graph the original x, y, z. Figure out the coordinates of x prime, y prime, z prime, and then graph x prime, y prime, z prime. And then we'll do a third one in this one over here, just to fill out all 3 of our types of rotations that we've got. But let's work on B first. So do that one. Take a couple minutes on that. Try to figure out where it ends up. There might even be a little bit of overlap between the original and the image, between the pre-image and the image. What's got on your paper? Feel free to take a look up here and see if it went okay for you. Any questions on that one? So for x prime, what we did is we took the original y value, and we put it here. Because the rule says take the original y value and move it to the position of x, but don't change the value. And then take the original x value, move it to the y value position, and then take its opposite. So basically, we're taking our 7 and we're putting it here. And we're taking our -4 and we're putting it here, but then we're taking the opposite of that. So it'd be +4. So that's where we get 7, 4 from. And then we do the same thing for the other two. Bring the y value of 8 into the x position, move 0 to the y position, and then take its opposite, which is still 0. So that's 8, 0. And then for z prime, take -1, which was the y value, move it to the x position here. Take 2, move it to the y position, and then take the opposite. So it becomes -1, -2. And so if you think about what happened, x has been rotated all the way around 270 degrees to there. Y has been rotated 270 degrees all the way around to here. And then z has been rotated 270 degrees to here. So all three of those have been rotated right around the middle of the graph to get from here to here. Any questions on that before we do one more example on this page? I'm going to add an additional example. Okay. Anybody need more time on this? All right. So what one do you think I'm going to add for this graph here? 90 degrees. Yeah, we haven't done 90 yet. So let's do a 90-degree rotation. So right here, we'll call this one C. And this will be, we'll do R, 90 degrees around the origin of triangle X, Y, Z. We'll graph X, Y, Z one more time. So there's X, Y, and Z. And this time we'll do a 90-degree rotation. Before we do this, where do you think this is going to end up? If we go 90 degrees counterclockwise, which is going to be 90 degrees that way, where do you think it's going to end up? Underneath, over to the right, or over to the left? Like in general. Left, yeah. So it's basically going to go, it's going to be rotated around the middle, so it'll be like that. If we take it here, we rotate, it'll be looking about like that. So let's get our coordinates. So go X prime, Y prime, and Z prime. Go ahead and work on those and get your 90-degree rotation on there. So we'll bring Y to the front and make it opposite, and then move X to the Y position to keep it the same. So that's going to be, what's that going to be for X prime? Somebody tell me. -7, -4. Good. How about Y prime? -8, 0. Nice. And then Z prime. 1, 2. Yes. Awesome. So those are our coordinates for X prime, Y prime, Z prime. Good, good. Let's get that graph. So -7, -4. Right there. So there's X prime. There's Y prime. And then 1, 2, Z prime. There. Our 90-degree rotation. So the big three things that we need to pay attention to today are the rules for our different rotations. Those are kind of the major things that we got. Now we are going to do some more like compositions of combining, and there will be some questions on your assignment with combinations of rotations with reflections and with translations. But we've already done compositions, and so, you know, combining a rotation is basically the same as combining translation with a reflection, which we've done already. So we're just going to introduce rotations into that mix. Does anybody need more time on this page before we look at the last page? Like I said, nice quick day of notes. Cool, flip it over. So this last one has to do with a marching band. So I'll kind of talk about this, and then we'll, investigate what's going on with it. So it says the illustration shows a drum line transformed by the rotation of 180 degrees around point A. And then it's rotating negative 135 degrees around point B. First of all, you will not need, in your assignment, you're not going to need to worry about numbers other than 90, 180, and 270, okay? This is just an example of like composing two different rotations, and this is more of a concept question as opposed to like using a protractor to figure out angles, so we don't need to worry about that. Suppose the drum line instead turns counterclockwise around point B prime for the second rotation. How many degrees must it rotate so that the drummer originally at point A ends up at A double prime as before? So that's a long-winded question, right? So we got to break this down a little bit, kind of figure out what's happening. So first of all, what it's saying has happened is let's see, drum line is going from point A to point B. This is the original positioning of the drum line, A to B. It says it's rotating 180 degrees around point A. So that's this right here. So it's keeping A where it was, and it's just rotating around right here. So where they end up, they march around this way. And so now A prime and B prime are here. A and A prime are the same spot because it was rotating around that point. But B went from over here to B prime over here. So now we're here. And then it says negative 135. Negative 135, if you see a negative here, all that means is it's a clockwise rotation. This means counterclockwise, so we're going this way, opposite rotation of the clock. Negative just means it's a clockwise rotation. So once we get to here, we're pivoting around B prime, and so it goes from here over to there. That's about 135 degrees there. So there's two things happening. It rotates around this way, around point A, and then it rotates this way around point B prime. It says, suppose the drum line instead turns counterclockwise around point B prime for the second rotation. So instead of going 180 degrees, instead of going 135 from here to here, it goes 135 from here to here on that second rotation. How many degrees must it rotate so that the drummer originally at A, who is now here, ends up at A double prime? So basically, we're trying to find the difference between, I'll go ahead and get some colors on here. So if they rotate 135 degrees, let's see, how many people are there? There's 1, 2, 3, 4, 5, 6 people. So 6 people like that. So instead of rotating up on the second one, they rotate down. That's what we're saying. How much farther do they need to go to get to A double prime? That's our question. What do we think? Any thoughts on how we could figure this out? I just want you to spend a minute on trying to work through what's going on. So we can maybe 90, okay. $225, okay. Any other thoughts? By the way, this right here would be, this is also a 135 degree rotation. What do you notice if I fill this in here? What's the general shape between these dotted lines? A circle. How many degrees are in a circle? 360. How many degrees are missing from that circle? Yeah. There's 90 degrees missing from that circle. Because we're trying to get to this point no matter what. A is trying to get here either way. So If he goes this way, 135, or down here, 135. So directly, it'd be 135 degrees from here to here. Indirectly, it would be 135 here, and then another 90 to get from here to here. So the answer here is, how many degrees must it rotate so that the drummer originally at A ends up at A double prime as before? So if you're turning counterclockwise, that means it's got to go 135 plus another 90. So that would be a 245 degree rotation, basically. Right? Mm-hmm. To the 135? No. Can you explain that again? I'm curious.
So if it faces like this.
Yeah.
Or I guess maybe it would be like this.
Mm-hmm.
If it rotated 180 degrees, it would be like this.
So you're talking about over here? Yeah. Okay.
270. This.
Uh-huh.
And I just.
Okay. So all the way around 225. Actually, so let's see, 135 plus another 90 would be, yeah, 225. You're right. Yeah. So it is 225. Yes. Yeah. 225. I said that. Because if you go 135 here and another 90 to get there, that is 225. You're right. So it would be a 225 degree rotation. So let's see, this would be how many degrees must it rotate so that the drummer originally at A ends up at A double prime? It would be, we would say this, R, and then 225 degrees around point B prime. That would be our answer for that. Because it'd be a 225 degree counterclockwise rotation as opposed to 135 degree clockwise rotation. It's basically whatever fills in to make the 360 degrees for the circle, it's the opposite of that. So 135 and 225 gives us 360, so that would be our answer. Can the composition, so here's our question here. Can the composition of rotations be described by R 45 around A? So if we rotate 45 degrees around the original point A, would that work? Think about a 45 degree rotation around point A to begin with. So for part B, I'm just going to circle point B here, and I'm going to draw an arrow over here to show that that's what I'm doing here. So if we do a 45 degree rotation around point A initially, that would actually just put us about right there. Roughly. A 45 degree rotation would put us about right there, which is definitely not where we ended up. So the answer is no. And the reason why for this is that compositions of rotations don't really work the same as compositions of translations. And you don't need to write that, but it doesn't quite work the same. And we can see it doesn't work the same here because, well, a 45 degree rotation certainly does not put us at the end. In fact, the only way for us to get to, and there's another reason for it as well, and that's because we changed our pivot point, right? The first pivot happened around point A, and the second pivot happened around point B prime. So there's actually no way to do a single rotation to get from the original to over here. That can't happen. There's no way to rotate around point A to end up with everybody like this right here. It just doesn't work. Because the pivot point changed. So that's just one of those kind of concept questions. We don't need to worry too much about the math on that so much, but that's what we got. All right, now the last thing I want to talk about here, example 4, is investigating reflections and rotations. And this is something that you will see on today's assignment. And it says the diagram shows JKLM and its image WXYZ. So we started off over here and we ended up over here. And you can definitely tell that those are rigid motions because the size of the image, WXYZ, is the same size of the pre-image, JKLM. The orientations are different, but the size and shape are the same, so it's a rigid motion. It says it's being rotated around point T. So that means that this was originally here, and it's just been rotated around to here, all the way around. You can obtain the same result using two reflections. So it says, first, draw a line P through point T and reflect JKLM across to form J prime, K prime, L prime, M prime. So I'm going to show you what that looks like. So we're going to choose a point P. All right. Draw a line P through T and reflect across. So let's see what that ends up looking like. So does it say where P is going to go? Doesn't really, does it? Not so much, which means it doesn't really matter where that ends up. But let's just go ahead and I'm going to just take what the book had here. So let's go ahead and draw a line about like that. Okay. We'll call that line P. So there's line P. And the idea here is we're going to go ahead and reflect JKLM across line P. Kind of like we did with our reflections lesson last Friday. So what we need to do is basically try to get 90 degrees from K to the line. So about like that. And then we're going to go the same distance across. So we'll have K prime right about there. So it's a reflection situation. And then J will be about here. J prime will be right about there. So we've got K prime. We've got J prime. And then L prime, let's see, L is going to be 90 degrees here. So about like that. And then that'll put us about there. So there's L prime. And then M will be about here. Let's see if this is actually going to work. It will work. I shouldn't say like I don't know, but that needs to be a little bit further. There we go. So it should look about like this. So J prime, K prime, L prime, and M prime. If we had a graph, it would be a little bit easier to make those a little more accurate. So that's a rough reflection. So it says, draw a line through T reflected. Okay. And then it says the midpoints of the segments connecting this shape to that shape would end up having our other line of reflection. So if we were to draw another line of reflection connecting the midpoints of these ones, so right here, right here, right here, and right here, those should still, the middle of those points, what it's saying is the middle of those points there, in between this reflection across this way, should still line up with T. And if you draw a line T through those points, you can see that that is true. So here's another line. If you draw it through, it ends up working. So basically what we're saying is that a rotation could also be a composition of two reflections. And those two reflections will always go through the point at which the things are rotated around. Or at least the lines of reflections will always go through the point at which those things are rotated around. As long as you put a point and then draw your line of reflection through that point of rotation and then reflect it again, you should get to the final image, and that second line of reflection should also go through point T. That's basically what it's saying. Now it says follow the same constructions, but instead draw a line P so that it does not pass through line T. So let's just say, let's draw a line this time and put it, let's see, I'm going to draw it like this. Here's line P this time. So this time I'm going to draw line P so it looks like that. This time line P does not go through point T. Do you think we're going to be able to go ahead and make another reflection so that it's going to work like it did with the original problem here? My guess is probably not, but let's see. So if we reflect, I'm just going to put P, line P like that, and I'm going to reflect across it. So if I go from here to here, let's see, that's about there for K. J is going to be about here, J prime anyway. L prime. Maybe a little bit further about there. And then M prime will be maybe right about there. So we got K prime, J prime, M prime is up here, and then L prime is over there. So that's roughly a reflection across that line P. Now, if we were to try to match up the midpoints here and draw another line of reflection, are we going to get the same results? And the answer is no, we're not, because the only way that we can do that is if we draw our original line of reflection, P, through the actual point where it's being rotated around, in order for us to actually get that nice two reflection situation. So that's kind of another concept that we're looking at. You might see a couple questions like this on your assignment. Hopefully they'll include some grids. If they don't, just, do a sketch like we do here. And again, as always, if you have questions, let me know. So I want to make sure you got a decent amount of work time today. So I'm going to pause it there for today. We're out of here at 11:01. So we have about 16 minutes or so, 15, 16 minutes to get going. Let me get your assignment handed out to you. Much shorter day of notes than the first two.